In a 30, 60, 90 special right triangle, there's an important ratio as we go from the shorter leg to the longer leg to the hypotenuse. And that ratio is 1, root 3, and 2. If we can remember this ratio in this similar triangle, we can then apply it to any 30, 60, 90 triangle. Key thing is that things go in the right place. Opposite the 30 degrees is always the 1, that is the smallest side. Opposite the 60 degrees is the root 3, and the hypotenuse would be 2. So we'll use that ratio to apply it similar triangles to the examples we have below. What we can also do is use the fact that the longer leg is the shorter leg times root 3. In addition, the hypotenuse is 2 times the shorter leg. So this allows us to write a ratio, which will then be our similar triangles. So next to the problem number 1, I'm going to draw my 30, 60, 90. 1, root 3, and 2 are the values that I need. From here I have similar right triangles, or similar triangles in general. I can go x over root 3 are corresponding, 5 over 1, and then y over 2. So by cross product, I can see between these two, I would get 5 times 2 equals y times 1, which is just going to tell me that y equals 10. For these two, when I do cross product, I get 5 root 3 equals x, or x times 1, so my answer is 5 root 3. In number 5, I'm going to draw my similar triangle again. So I have 30 degrees here, 1 goes opposite there, root 3 and 2. So our ratios are going to be x over 2 equals y over root 3 equals 14 over 1. The first two I can look at are these two, x over 2 and 14 over 1. By doing cross product between those, I get that x is going to be 28. And now for the last two, for y, I'm going to use the last two fractions. So y times 1 is y, and then 14 times root 3 is just 14 root 3. For number 6, we're going to draw our special right triangle. 30 degrees here, goes 1, root 3, and 2. So we'll have x over 1, y over root 3, and 32 over 2. I'm going to take these two ratios first. X over 1 equals 32 over 2. I could reduce 32 over 2 and make it 16 over 1. That is also what we'd get for cross product. So I see that x equals 16. And then now for y, I'm going to go y over root 3 equals 32 over 2. This becomes 2y equals 32 root 3. But then I can divide both sides by 2, which gives me y is equal to 16 root 3. For number 7, we're going to go 30 degrees here, 60 degrees here, 1, root 3, and 2. Our ratios will be x over root 3, y over 1, and 46 over 2. If I want to reduce one of them, I could reduce this 46 over 2, which gives me 23 over 1, and I pick the two fractions that make things easier for me. Y over 1 and 23 over 1 tells me that y is 23. And then I'm going to take x over root 3 and 23 over 1, and I get that x equals 23 root 3. For number 8, we're going to draw our special right triangle, 1, root 3, and 2. So it becomes x over 2, y over 1, and 20 over root 3. Let's solve for y first. Between those two, I get y times root 3 equals 20 times 1, or just 20. This is then 20 over root 3. Now we have to simplify this. We can't leave the radical in the denominator. So we're going to go 20 over root 3, multiply the top and the bottom by root 3, which makes the top 20 root 3, and it makes the bottom into 3, because root 3 times root 3 is the square root of 9. So now, for y, we get 20 root 3 over 3. I can go back to my original proportion. I'm going to fill that value in for y and say 20 root 3 over 3 over 1. When I do cross product here, 2 times 20 root 3 over 3 becomes 40 root 3 over 3 equals x, and that would be my answer for x. Number 9 is our last one. We'll draw our triangle here. We're going to go 1, root 3, and 2. So our ratio will be x over 1. Then we'll go y over 2, and 9 root 3 over 3. Root 3. So first, let's take x over 1 and 9 root 3 over 3. We do cross product there. I get x times root 3 equals 9 root 3. I can divide both sides by root 3, and x is 9. We do the same thing for y. We take these two fractions. I get root 3 times y equals 2 times 9 root 3, which is 18 root 3. Divide away the root 3's, and y is 18.